In the space of science and tremendous secrets, the subject of what existed prior to the tremendous blast has sparked mixed discussions and captivated minds for a long time. This colossal question doesn't simply test how we might unravel the universe. It challenges the very limits of human knowledge. Imagine standing at the edge of existence, exploring the vast unknown and pondering what lay there before our universe was conceived. The event of the Big Bang marked the dawn of humanity, space, and everything we know. But was there a moment before it? Could there have been a state of nothingness, a silence before the cosmic gathering began? Or perhaps there was something even more profound that existed before time itself. As we delve deeper into this question, science takes us on a journey beyond the universe's beginning into realms that challenge our understanding. Physicist Brian Cox, known for his insights into the wonders of the universe, suggests that something astonishing could have existed before the Big Bang. He encourages us to rethink our notions of reality and existence. In this exploration, we'll dissect the science, theories, and fascinating secrets that may uncover what existed before everything. We'll examine concepts like quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astound us, but could also open new understandings of our place in the cosmos. Prepare to dive deep into a world beyond imagination and science, where the unknown still weaves mysteries that leave scientists both amazed and unsettled. Let us explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what might have existed before the Big Bang, we must first carefully examine what the Big Bang truly was. Scientists define the Big Bang as the moment when the universe became incredibly hot and dense, expanding rapidly to give rise to all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this fiery beginning, with galaxies spreading out from an early starting point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there was indeed something preceding the Big Bang, and it was far from empty or tranquil. Cosmic inflation suggests that before the Big Bang, the universe existed in a cold, empty, and sparse state, much like a vast vacuum. However, this vacuum wasn't truly empty. It contained an immense amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, happened so quickly that it effectively set the stage for everything that followed. In a fraction of a second, space expanded at unimaginable rates until the expansion slowed, and the energy transformed into matter, particles, and the forces we observe as the Big Bang. What was the nature of this energy? Why did it suddenly expand the universe, and why did it stop? Scientists believe that this infinite expansion created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests that there are possibly countless Big Bangs and an infinite number of universes. Ours is just one of many. This mind-bending reality challenges our understanding of the universe and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is speculative at best. Even if we remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an intricate network of existence, even in its most minimal state. Even if we imagine stripping away all these forces to leave a void, the universe would still generate new forms of energy. This reality perplexes scientists as it suggests that true nothingness may be impossible within our understanding. Space itself has properties, rules, and constants that prevent it from being entirely empty. Quantum field theory adds another layer to this mystery. According to this theory, the universe is not just a collection of matter floating in space, but a complex network of energy fields that fill the cosmos. These fields are like invisible oceans, with particles acting as waves or disturbances. Even at their lowest energy levels, known as the vacuum state, these fields remain active. Particles can appear and disappear within these fields, briefly borrowing energy before returning it. This phenomenon results in virtual particles, substances that exist momentarily and then vanish, leaving only a faint trace. This challenges the idea of a true void and suggests that even before the Big Bang, there was something scientists are only beginning to understand. Dark energy, a mysterious force driving the accelerated expansion of our universe, may have existed before the Big Bang. Some theories propose that dark energy in a much stronger state might have powered the inflationary phase, causing rapid expansion. The presence of dark energy implies that even if our universe were stripped of all matter and radiation, this force would continue to expand the fabric of space-time. This leads to a profound question. If dark energy was present before the Big Bang, could it have created the conditions that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true origin of our universe? Another theory offering an alternative to the Big Bang as the ultimate beginning is cyclic cosmology, the idea that the universe goes through infinite cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event, but part of a timeless rhythm where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The process of cosmic rebirth challenges our notions of beginnings and endings, proposing an eternal cosmic dance of creation and destruction. These ideas push the boundaries of our understanding and force us to confront profound questions about existence, reality, and the nature of the cosmos. As we explore these possibilities, we uncover a universe that is far more complex, mysterious, and awe-inspiring than we could have ever imagined. The cyclic model suggests that each universe is part of an eternal sequence, where the end of one universe gives rise to the next. In this perspective, the Big Bang may have been the result of the collapse of a previous universe. As it shrank to an incomprehensibly small point, the intense forces and energy created conditions that ignited the next cycle, leading to our current universe's birth. This theory is compelling because it challenges the notion of a singular beginning. Instead of a universe with a definitive start and end, we are faced with a cosmic rhythm that has no beginning or conclusion. Each cycle is both an end and a beginning, creating a continuum of existence that defies our conventional understanding of time and causality. Another idea gaining traction is the possibility of quantum fluctuations giving rise to the universe. In this view, the cosmos may have originated from a quantum event in a pre-existing quantum field. Quantum mechanics, with its strange and counterintuitive rules, allows for the spontaneous creation of particles and energy from seemingly nothing. The implication here is profound. The universe could have emerged from a vacuum filled with fluctuating quantum fields. These fields, even at their lowest energy state, are never truly empty. They contain potential energy that can give rise to particles and forces, sparking events like the Big Bang. In this framework, nothingness is not the absence of everything, but a seething, dynamic realm of potential. Quantum fluctuations could be the seeds of universes, suggesting that the creation of our universe might not be a unique event, but part of an ongoing process occurring across the vast expanse of a multiverse. The multiverse hypothesis is perhaps one of the most mind-bending theories in modern cosmology. It proposes that our universe is just one of countless others, each with its own physical laws, constants, and dimensions. Some universes might resemble ours, while others could be drastically different, operating under entirely unfamiliar rules. If the multiverse exists, it raises profound questions about our place in the cosmos. Are we an insignificant part of an endless ensemble of universes? Could other universes harbor life, intelligence, or phenomena beyond our comprehension? The multiverse theory also suggests that the Big Bang wasn't the beginning of everything, but merely the birth of our local universe. Other universes might have their own Big Bangs, creating a vast and interconnected cosmic network. As we delve deeper into these theories, we confront the limitations of our understanding. Concepts like time, space, and causality become fluid and ambiguous. The idea of a beginning loses meaning in a framework where time itself might be an emergent property of the universe. Even more astonishing is the possibility that there was no before the Big Bang in the traditional sense. In some models, the Big Bang represents the creation of time itself. Asking what existed before might be as nonsensical as asking what is north of the North Pole. Yet the human drive to understand persists. These theories, whether they involve cyclic universes, quantum fluctuations, or a multiverse, expand our horizons and push us to question the very fabric of reality. As our knowledge grows, so too does our sense of wonder. The cosmos, with all its mysteries, invites us to explore, to imagine, and to seek answers to the profound question: what existed before the beginning? Perhaps we may never fully know, but in our quest to understand, we deepen our connection to the universe and our place within it, transcending the boundaries of what we once thought possible. Withdrawal and development in a cyclic example would truly intend that there was never a genuine beginning, but instead a timeless series of universes arising, developing, and restoring themselves again and again. Cyclic cosmology raises critical inquiries regarding time, as it proposes that time itself may be repetitive rather than linear. Assuming this hypothesis is correct, it could imply that what existed before the Big Bang was simply another adaptation of the universe, one that collapsed solely to give birth to our ongoing universe. For specialists, this hypothesis offers a rich reply to the subject of ultimate beginnings, suggesting that there is no obvious starting point. The universe has consistently existed in some form, transcending our concepts of time and existence. Early-stage gravitational waves are another fascinating idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in space-time caused by massive cosmic events, and scientists believe that primordial waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as the echoes of what preceded the Big Bang. If they are identified, they could provide evidence of the universe's past states. The potential discovery of early-stage gravitational waves would be a groundbreaking leap in our understanding of the universe. The idea of eternal universes forming and collapsing, waves disrupting the very fabric of time, and mysterious forces creating and pushing the boundaries of existence challenges not only our current understanding of the universe, but also forces us to confront our deepest existential questions. As we delve deeper into the mysteries of what existed before the Big Bang, we must explore other speculative theories that could offer glimpses into a universe beyond our own. One such idea is the concept of the no-boundary condition, proposed by physicist Stephen Hawking and others. This theory suggests that the universe does not have a traditional beginning as we understand it. There is no specific starting point. Rather, the universe could be like the surface of a sphere, without edges or boundaries. According to this hypothesis, the universe's beginning is essentially an illusion created by the flow of time, which may curve back on itself so that the concept of a starting point becomes redundant. In this view, the Big Bang is not the origin of the universe, but rather the transition point of a continuous cycle. If this hypothesis is correct, then asking what happened before the Big Bang becomes a meaningless question, as there was no time before that event. Another theory that takes a profoundly different approach to the question of what existed before the Big Bang is the idea of quantum foam. At the smallest scale, the universe is governed by quantum mechanics, and one of its most remarkable implications is that empty space is not truly empty. Even in a vacuum, quantum fluctuations occur, causing particles to spontaneously pop in and out of existence. These fluctuations might form a kind of foam at the tiniest scales, where space-time itself is subject to turbulence and unpredictable changes. This quantum foam may have been the precursor to the more familiar structure of the universe that we observe today. In this view, the Big Bang could have been the moment when the quantum foam transitioned into the smooth space-time we experience, effectively bringing our universe into existence from a state of extreme quantum uncertainty. This idea has profound implications for our understanding of time, space, and causality. Some scientists have proposed a more philosophical framework for understanding the origin of the universe. The idea of a cosmic egg or a pre-universe that existed in a collapsed state. This speculative model envisions a time when the universe was a single, infinitely dense point, known as a singularity, before the Big Bang. This singularity could have contained all the mass, energy, and information that would eventually lead to our entire universe. Over time, some propose this cosmic egg may have been subject to a kind of cosmic breathing cycle, expanding and contracting in cycles. The birth of our universe may have been the result of one such expansion. Eventually, it could collapse back into a singularity again. This cycle of birth and rebirth could have continued infinitely, and our current universe might just be the latest iteration of this cosmic cycle. Such a model challenges conventional ideas of linear time and posits that time itself could be cyclical, with no absolute beginning or end. On a more speculative note, some theories suggest the possibility of a multiverse, a collection of parallel universes, each operating under its own set of physical laws. In the context of the multiverse, the Big Bang of our universe could have been just one event among countless others, each giving rise to a different universe. The multiverse theory posits that there could be infinite universes, each with its own unique history, laws of physics, and even different versions of reality. Some scientists believe that the existence of a multiverse could explain certain features of our universe, such as its fine-tuning. If there are countless other universes with varying properties, then it would be no surprise that one of them is capable of supporting life as we know it. The holographic principle is another intriguing theory that suggests the nature of our universe might not be what we think it is. According to this principle, all the information that makes up the universe could be encoded on a two-dimensional surface, like a hologram. This idea, rooted in black hole physics, proposes that our perception of a three-dimensional universe might be an illusion, a projection of information encoded on a distant surface. If this idea is correct, then the entire universe, and possibly even what preceded it, could be seen as an intricate pattern of information. The holographic principle suggests that, much like a hologram, our universe could have emerged from a much simpler, lower-dimensional structure, potentially explaining how something as complex as the universe could arise from seemingly empty space. Finally, we must also consider the role of string theory, which proposes that the fundamental building blocks of the universe are not particles, but tiny vibrating strings. These strings could give rise to everything we experience, from matter to forces, and they exist in higher dimensions beyond the familiar three-dimensional space. Some versions of string theory even suggest the existence of additional dimensions of space that we cannot directly perceive. In this framework, the Big Bang could have been the result of interactions between these higher dimensional strings, leading to the creation of our universe. If string theory is correct, the universe may have been born from a higher dimensional space that is beyond our current understanding, adding yet another layer to the question of what preceded the Big Bang. These theories, ranging from the quantum to the philosophical, all present fundamentally different perspectives on the origins of the universe. While we may not yet have the tools to fully answer the question of what existed before the Big Bang, each new hypothesis brings us closer to understanding the nature of our reality and the universe's ultimate beginning. Whether through the lens of quantum mechanics, cosmology, or string theory, the quest for answers continues to push the boundaries of human knowledge. Each of these hypotheses, whether rooted in mathematics, physics, or philosophy, offers profound implications not only for the origins of the universe, but also for the nature of existence itself. If time is cyclical, or if the universe exists as part of an infinite multiverse, it challenges our deepest notions of causality, permanence, and the linear progression of events. For instance, the cyclic cosmology model raises a fascinating possibility that we, as observers, are simply participants in one iteration of an eternal process, with no true beginning or end. This view fundamentally shifts our understanding of time, suggesting it is not a straight arrow, but a loop, endlessly repeating. In contrast, Quantum foam theories highlight the enigmatic relationship between order and chaos. If the universe emerged from a frothy quantum state, it hints at a world where structure and randomness coexist, a delicate balance that allowed the cosmos to form from seemingly nothing. The multiverse theory, while speculative, adds a staggering sense of scale to existence. If countless universes exist, then the story of our universe may not be unique, but one of many, a drop in an ocean of realities. This raises compelling questions. Could other universes contain entirely different forms of life or intelligence? Might they operate under laws of physics unrecognizable to us? The holographic principle takes this speculation further, challenging our very perception of reality. If our three-dimensional universe is a projection of information stored on a two-dimensional surface, it forces us to rethink the nature of space, matter, and consciousness itself. What does it mean to exist in a reality that may, at its core, be an illusion? String theory, too, opens doors to extraordinary possibilities. Its higher-dimensional framework suggests that what we perceive as the universe might only be a small part of a much larger, more intricate system. If our universe was birthed from interactions between higher-dimensional brains, it could imply that our reality is shaped by forces and dimensions far beyond human experience or comprehension. The human quest for answers. As scientists, philosophers, and thinkers continue to probe the nature of the universe, they are not only exploring the physical realm, but also confronting profound existential questions. What is the purpose of the universe? Is there an inherent meaning to existence, or are we simply the byproduct of cosmic processes? Such inquiries, though rooted in science, inevitably intersect with philosophy, spirituality, and metaphysics. They compel humanity to grapple with concepts that defy conventional understanding: infinity, eternity, and the interconnectedness of all things. The journey to uncover what existed before the Big Bang is more than a scientific endeavor. It's a testament to humanity's insatiable curiosity. Whether through advanced telescopes peering into the farthest reaches of space, particle accelerators probing the smallest scales of matter, or mathematical models imagining higher dimensional realities, each discovery brings us closer to understanding our place in the cosmos.